Hello and welcome everyone. I am Megakshi Rana, your mathematics teacher on Study Room. Today we are going to learn about chapter number 3 of our class 8th mathematics, and the name of the chapter is Understanding Quadrilaterals. So in this video we are going to learn what quadrilaterals are, their types and a lot more new things, and then the examples. So first of all, what are curves? So what is the definition of a curve? A curve is a geometrical figure obtained when a number of points are joined without lifting the pencil from the paper and without retracing any portion. It is basically a line that need not be straight. So what is a curve actually? A curve is actually a geometrical figure that is obtained when a number of points. So take for example, these are some of the points, and when we join all these points, without lifting the pencil from the paper and without retracing any position, we get a curve. So this is a curve actually, and it need not be straight. It is a line that need not be straight. Now what are the types of curves? So there are various types of curves. One of the types is open curve. So what is an open curve? An open curve is a curve in which there is no path from its point to the same point. Okay, so that is what an open curve is, where there is no path from its point to the same point. And a closed curve is a curve that forms a path from any of its point to the same point. So if like this point we come back to this point, then that curve will be known as a closed curve. While if we are starting from this point, or if we have this point and there is no path back to the same point, then such a curve is known as an open curve. So these were the two types of curves. Let us see some examples. So you can see this figure. This type of a curve is a closed curve. Why can we call this curve a closed curve? Because if there is this point, we are getting, just see, if this is a point, taking this point in this curve, on this curve, we are getting a path back to this point. That is why it is a closed curve. Now see that this is known as an open curve. But why it is an open curve? Because see, if this is our point, then we're going from here, but we are not getting any path back to the same point. That is why it is an open curve. The last figure, you can see that it is a star type of a figure. What is it? It is a closed curve that is not simple. So yes, it is a closed curve because if we consider a point here, our point, if we have a point here, we are coming back. We gonna come back to the same point back. We are getting our path back to this point. That is why we can say that this is a closed curve, but it is not a simple curve. It is a very complex closed curve. Now we have polygons. So what is a polygon? First of all, the question that arises is, what is a polygon? So a simple closed curve made up of only line segments is called a polygon. The line segments forming a polygon are known as sides, and their endpoints are known as the vertices. So the endpoints of these line segments will be called as vertices, and all these line segments that form the whole polygon are called the sides of that polygon. The sides of a polygon does not cross each other. So a polygon is just a simple closed curve that is made up of only line segments. Now we'll just illustrate some of the polygons. See, curves that are polygon. Now why are these three curves called polygons? Because you can see that these are simple closed curves, and these are only formed of the line segment. This is a line segment, this is a line segment, these four are the line segments. Similarly here, these are the line segments, these are the line segments. Okay, you can see, and it is closed, so it is a polygon. Now you can see these line segments will be called what? These line segments will be called the sides of this polygon, while their endpoints, this point, okay, all these points will be called the vertices. Here also all these endpoints of these line segments will be known as the vertices of this polygon. Whereas these figures, what are these? These are the curves that are not polygon. So why are these curves not called polygon? Because you can see that this is a closed figure, but this is not a closed curve. Here, these points do not have a path back to the same point. We can say that these are not similarly this one, because the lines are crossing each other. Here, the lines are crossing each other. Here, the lines are not closed. This is not a closed curve. That is why it is not a polygon. The lines, because in the definition, what we saw, we read that the sides of a polygon does not cross each other. The sides should not be crossing each other. But here, the sides are crossing each other. Here, the sides are not closed. The curves are not closed. Here again, the sides are crossing each other. That is why all these three are not considered to be polygons. Next, we are going to classify polygons. On the basis of what? On the basis of the number of their sides. So let's see, we are going to classify polygons according to the number of the sides or vertices they have. The number of their sides or the number of the vertices they are having. You can see that the number of sides in this sample figure are 3. 1, 2 and 3. Or you can see that the number of vertices are 3. So such a polygon that has 3 sides or 3 vertices is known as a triangle. So we can call this type of polygon as a triangle. So what is a triangle? A triangle is a polygon that has 3 number of sides or 3 vertices. What is our next polygon? Here we are having this sample figure. Now how many sides it has or how many vertices it has? It has 1, 2, 3 and 4 sides, or you can say vertices. So a polygon with 4 sides or 4 vertices is known as a quadrilateral. So what is this? This polygon is known as a quadrilateral. Our next polygon is, you can see the sample figure. Now how many sides does this have? 2, 3, 4 and 5. It has 5 sides or it has 5 vertices. So a polygon with 5 sides or 5 vertices is known as what? You can call it a pentagon. So a pentagon is a polygon with 5 sides or 5 vertices. I have here a sample figure. Now you can see that this sample figure has how many sides? 2, 3, 4, 5 and 6. So it has 6 sides or 6 vertices, and such a polygon with 6 sides or 6 vertices is known as a hexagon. While a polygon with 7 sides or 7 vertices is known as a heptagon. You can see the example of a sample figure. It has 7 sides or 7 vertices, and such a polygon will be called a heptagon. Next one is an octagon. So what is an octagon? A polygon with how many sides? 2, 3, 4, 5, 6, 7 and 8 sides or 8 vertices is known as an octagon. While a polygon with 9 sides and 9 vertices is known as a nonagon. You can see that this polygon has how many sides or vertices? 9. So that is why it is known as a nonagon. Next we have a polygon with 10 sides or 10 vertices. That is called a decagon. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So polygon with total 10 sides or 10 number of vertices will be known as a decagon. You need to remember all the names of these polygons. So next we have diagonals. Now what are diagonals? A diagonal is actually a line segment that connects two non-consecutive vertices of a polygon. So you can see that here PS or QR will be called a diagonal. Why these two are the diagonals of this figure? Because these are connecting the non-consecutive vertices. See, the consecutive vertices of P will be Q and R, and S is the non-consecutive vertices as when we take P as our vertices. So vertex, so P and S, the line segment that is connecting P with S or Q with R will be called a diagonal, because it is such a line segment that is connecting two non-consecutive vertices of a polygon. Similarly, you can see this polygon. Now this will be called a 1, 2, 3, 4, 5. So this polygon has 5 sides or 5 vertices. So what it will be called? It will be called a pentagon. Now this pentagon has this AD, this BD, this EB, EC, CA, all these are the diagonals of these polygons. Why? This polygon, why? Because all these line segments are connecting the non-consecutive vertices with each other. Similarly, these, you can see that this is actually a triangle, and you can see that this polygon is having all these diagonals. These are the diagonals of this polygon. Why? Because these are such line segments that are connecting two non-consecutive vertices. Next topic is interior and exterior of a closed curve. You can see both of these are closed curves. Point P is in the interior of closed curve. You can see that this is a closed curve. We have this closed curve. I'll be naming this polygon as ABCD. We have this ABCD, a closed curve or a polygon, and this point P, as it lies inside this polygon, so point P is in the interior of closed curve. What do we say? We say that this point P is in the interior of this closed curve ABCD. While we can see that again this ABCD is the closed curve of the polygon. Now, since point P, this is the point P, it is lying outside this closed curve, so we will call it as that the point P is in the exterior of the closed curve. What do we say? We will say that this point P is in the exterior of the closed curve, and while this was in the interior of the closed curve. Now, how do we classify polygons on the basis of their shape? We have already studied the classification of polygons on the basis of the number of sides they have or the number of vertices they have. Now, on the basis of shape, polygons are classified as concave or convex based on the shape they have. So, what is a concave polygon first of all? A concave polygon is a polygon in which at least one of its interior angle, these are the interior angles of this polygon. If one of the interior angles is greater than 90 degrees, then such a polygon will be called a concave polygon. So when is a polygon called a concave polygon? When at least one of the interior angle, you can see that these four angles are the interior angles of this polygon. If at least one of these interior angles will be greater than 90 degree, then such a polygon will be called a concave polygon. And the polygons that are concave have at least some portions of their diagonals in their exterior. Some of their diagonals are going to be in the exterior, okay, like this. So some portions of the diagonals is going to be in the exterior. Now again, you can see in this polygon also, all these are the interior angles. You can see that at least one of them is greater than 90 degrees. That is why this polygon is a concave polygon. Similarly, that is why both of these polygons are concave polygon. Now next up is the convex polygon. So convex polygon is a polygon with all its interior angles less than 180 degree. Polygons that are convex have no portions of their diagonals in their exterior, okay? So what is a convex polygon? A polygon with all the interior angles less than 180 degree. If all the interior angles of a polygon are less than 180 degree, then such a polygon will be called a convex polygon. You can see the examples of the convex polygons. All the angles will be less than all the interior angles, right? We are not taking the exterior ones, but the interior angles. When all the interior angles of the polygon are less than we say 180 degree, then such polygons are called convex polygons. Now the polygons that are convex have no portions of the diagonals in their exterior. No portion of their diagonal is going to be in the exterior. No portion of their diagonals will be in the exterior. They will lie in the interior only, okay? So these are the diagonals, and we can see that all of their portion is lying in the interior only and not in the exterior. Next up is the classification of polygons on the basis of their regularity. So how regular are these or not regular? Then according to such basis, polygons are classified as regular polygons and the others to be irregular polygons on the basis of their regularity. On the basis of the regularity of the polygons, polygons are classified as regular polygons or irregular polygons. Now first of all, regular polygons. So when a polygon is both equilateral and equiangular, it is called as a regular polygon. What is a regular polygon? A regular polygon is such a polygon that will be both equilateral, just mark these two terms, such a polygon that is both equilateral and equiangular will be a regular polygon. Example is a square. Why a square? Because it will have all the sides equal as well as all the angles equal. All the sides of a square are equal, we know that, and all the angles of a square are equal, we also know that. That is why, because a square is both equilateral and equiangular, that is why a square is an example of a regular polygon. So there are some more examples. See, this is a square. These lines mean that all these sides are equal. That is why it is equilateral. Okay. Now equiangular, we know all the angles of a square are 90 degrees. So a square is both equiangular, equilateral. That is why a square is an example of a regular polygon. Similarly, if we see this polygon is again has all the sides equal, all the angles equal. That is why it is a regular polygon. If we see this triangle, this has all the sides equal, all the angles equal. That is why it is both equilateral, equiangular. That is why it is an example of a regular polygon. What is the other type of polygon? The other will be irregular polygon. Now a polygon which is not regular will be an irregular polygon, which is not regular. Not regular means not equilateral, not equiangular. Such a polygon that is not regular or that is not equiangular, not equilateral is known as an irregular polygon. So here we have an example. See, these two sides are equal, but these two sides are equal to each other, but these are not equal. We can say that all the four sides of this polygon are not equal, while the angles, it is equiangular, but it is not equilateral. It is a rectangle. And rectangle is actually an example of irregular polygon. We can say, because why is rectangle an example of an irregular polygon? Because it is equiangular. We know that all the angles of a rectangle are 90 degrees, but since all the four sides of a rectangle are not equal, that is, it is not equilateral. That is why rectangle is actually an example of an irregular polygon. Similarly, we can say this is actually an example of irregular polygon, because here these two sides are equal and these four sides are equal to each other, but not all the sides are equal. Similarly, not all the angles are equal for this polygon. That is why it is an irregular polygon and not a regular polygon. Similarly, these two sides are equal, not the other sides equal. Similarly, these two angles are 90 degrees while other angles are not 90 degrees. That is, all the angles and all the sides are not equal, so it is an irregular polygon. Angle sum property of a polygon. So what does the angle sum property of a polygon says? According to the angle sum property of a polygon, the sum of all the interior angles of a polygon is equal to how much? It is equal to n minus 2 into 180 degree. Where what is this n? N is actually the number of sides of the polygon. So what does this angle sum property of a polygon says? It says that the sum of all the interior angles is going to be n minus 2 into 180 degree. Again revise, the angle sum property of polygon says that the sum of all the interior angles of a polygon is equal to n minus 2 into 180 degree, where this n is the number of sides that polygon has, n minus 2 into 180 degree. Take for an example, for a quadrilateral, we know that n equals to 4 because a quadrilateral has how many sides? It has 4 sides. So according to the theorem, sum of all interior angles, or according to this theorem, that angle sum property of polygon, according to this property of polygon, or the sum of all interior angles will be n minus 2 into 180 degree, that is 4 minus 2 into 180 degree, that is 2 into 180 degree, or we can say 360 degree. Now we have the proof of this theorem. How does we go about it? How do we go about it? See, angle sum property of a triangle says that the sum of the measures of the three angles of a triangle is 180 degree. Why can we say that the sum of the measures of the three angles of this triangle is going to be 180 degree? Because in the case of triangles, n will be 3. N will be 3, so 3 minus 2 will be 1, and 1 into 180 degree is going to be 180 degree. So that is why the sum of the three angles of a triangle is said to be 180 degree. Now draw a quadrilateral ABCD. Let P be any point in its interior. Join P to vertices A, B, C and D. Now let's just see this from this figure. See, we have this A, B, C, D quadrilateral. We are joining these points. What was written? Let P be any points in its interior. We are taking a point in the interior of this quadrilateral and this point is said to be P. We are joining all these vertices with P. In triangle APB, we already know that the sum of all the three angles of a triangle is going to be 180 degree. Now from this statement, we are going to finally prove this angle sum property of polygon. We are going to join all these vertices of this quadrilateral with P. We are getting some triangles, triangle APB, triangle BPC and triangle CPD, and the other one is triangle DPA. By angle sum property of triangle, we can say that this angle x will be equal to 180 minus 2 and 180 minus angle 2 and minus angle 3. Why? Because all the sums of these three triangles is going to be 180 degree. All the sum of these three angles is going to be 180 degree, and all the sum of all these three angles is going to be 180 degree, and similarly the sum of these 8, W and 1, these three angles is going to be 180 degree. So we can just derive from there that angle x is going to be 180 minus 2 minus angle 2 minus angle 3. Angle y is going to be 180 minus angle 4 minus angle 5. Similarly, angle z is going to be 180 minus angle 6 minus angle 7, and angle w is going to be 180 minus angle 8 minus angle 1. Again, we know that this x, y, z, w, their sum is going to be what? Their sum is going to be 360 degree. We know this also, and we know all these things also, right? We know this also and we know this also. Now the sum of these four angles is going to be 360 degree. That is, when we are going to add this angle, these four angles together, we are going to get 360 degree. So see, 180 minus angle 2 minus angle 3 plus 180 minus 4 minus angle 4 minus angle 5 plus 180 minus angle 6 minus angle 7, and the last one 180 minus angle 8 minus angle 1. The sum of these four angles is going to be 360 degree. After solving this, we are going to get that angle A, angle 1 plus angle 2, that was angle A. Angle 3 plus angle 4, that was angle B. Angle 5 plus angle C, that was angle C, and angle 7 plus angle 8, that was our angle D. The sum of these four angles is coming to be 360 degree. So we can say that yes, the sum of all interior angles is coming to be 360 degree and hence proved. So we started from the statement that we know that the sum of the three angles of a triangle is equal to 180 degree. We consider all these four triangles, and we, using all these two statements, we concluded that the sum of all interior angles of this quadrilateral of this polygon is 360 degree. The sum of the measures of the exterior angles of a polygon. So first of all, we studied about the sum of the interior angles, and now the sum of the exterior angles. How is it given? The sum of the measures of the external angles of any polygon is 360. So this is just a sentence that is, it is a fact actually. It is always going to be true that the sum of the measures of all the external angles of any polygon is going to be 360 degrees. So in this figure, we can check that this angle 1 plus this angle 2 plus this angle 3 plus this angle 4 plus this angle 5. Measure of angle 1, 2, 3, 4, 5, when all these 5 are going to be added, since all these angles we can see are the exterior angles of this ABCDE polygon. When all these angles will be added together, their measure will be added together, we are going to get 360 degree, and this is a fact that the sum of all the exterior angles of a polygon equal to 360 degree. Let's do some examples related to the topics we have learned just now. First example is example number 1, and it says that we need to find measure of x, angle x. We can see that in this polygon, angle x, angle 90 degree, this angle 50 degree, this angle 110, all these 4 angles are actually the exterior angles of this polygon. What are these? These are actually the exterior angle of the polygon, and we have just studied that the sum of the measures of the external angles of any polygon is 360 degree. So just from the previous statement, we can say that when angle x will be added with 90 degree, will be added with 50 degree, and it will be added with 110 degree, what are we going to get? The sum will be 360 degree. We can solve this equation. Add 110 with 50 with 90 in your rough side, you are going to get 250. So x plus 250 degree is going to be 360 degree. We'll take this 250 degree to the other side. We are going to get 360 minus 250 degrees. 360 minus 250, you can do it in the rough work, getting 110. So what is the measure of this x angle? It is 110 degree. What is our x angle? 110 degree. And how did we find it? We used that the sum of the measures of the external angles of any polygon is 360 degree. Since all of these 4 angles were the external angles, we added these and we got 360 degree. We solved this equation and we found out the measure of angle x. Next up is example number 2. Find the number of sides of a regular polygon whose each exterior angle has a measure of 45 degree. Now what is given? We are given that we have a regular polygon and each of the external angle has a measure of 45 degree. We need to find the number of sides. So we know that sum of all external angles for such a polygon, external angles will be 360 degree. And each of the exterior angle is it is given, right? Each exterior angle is given us to be 45 degree. So what will be the number of sides? Number of sides of this polygon is going to be what? How can we do this? 360 divided by 45. 360 when divided by 45, that is going to give us the number of sides. You can do this you can just write so how many sides? 8 sides. This polygon is going to have 8 sides because we already knew that external angles, the sum of all the external angles is going to be 360 degree. Since each of the exterior angle was 45 degree, when we divide 360 by 45 degree, we are going to get the vertices, or we can say that the number of sides of that polygon. So it came to be 8. So this polygon has 8 sides. This was all about our video lecture 1 for this chapter number 3. In the next video, we are going to learn about the types of quadrilaterals. We'll join again in the next video. Till then, bye bye. See you next time.